the Hadoop ecosystem, different packages that will also help us manage the data. We mentioned we spoke about HBase, so we started with HBase. Does anyone remember any major difference between HBase, the way HBase is built, and Hive? Can anyone remember? Does anyone remember the main difference between HBase and Hive? Does anyone remember? Anything? Or anything? What do you remember about HBase? Anything specific you remember about HBase? Anyone? Guys? I think everyone is supposed to answer this question because you even have it on your screen, unless you cannot see my screen. Anyone remember anything about HBase database?
HBase is structured like Microsoft Excel.
What does it mean? What does it mean? What do you mean by that?
There's a tabular-like structure.
Okay. Yeah. So basically, HBase is just a column-oriented database, okay, that's run on the Hadoop file system. Okay. So HDFS, which stands for Hadoop Distributed File System. So we have HBase as a database that works there. So HBase is basically designed to handle massive amount of data across clusters of hardware. So we have many servers, we have many data all over. We can handle them in a column-based database. So remember, we mentioned how the column are. We have a column family. For example, here we have info, which is a column family, and then we have different columns. And then in the columns, we have different rows. So each row, we have a row key for each row, and then we have cells. So cells will contain the data. And remember, one of the most important things that we said is, in case you modify anything from a cell, the database will create a timestamp for each modification. So basically, you can get the previous data. So some of the characteristics to note, we have the fact that it's column-based, okay? It's column, or we can say column-oriented storage. So we have columns, right? Which is unlike some database. With HBase will store the data by columns rather than just rows, right? This will be really more efficient in terms of queries, in terms of getting this data to be used in our system. Okay, so we have another important thing is we can have what we can call an high availability. So basically, with with HBase, all the data are available anytime. So we can access the data anytime. So no matter how big the database is, we can access that. We spoke about a server that we can call a HMaster, which is the main server, right? Which will manage all the tables metadata, right? So the part of the server that will do that will be called the HMaster. And then we have the rest of the servers will be the, can anybody remember how do we call the other servers that will serve the data for read and write? Remember we have the HMaster, which will, HMaster server. So this server will just manage the table metadata and region assignment. What about the other servers? How do we call them in HBase? Does anyone remember? We have the HMaster server, and what about the other servers? How do we call them?
Are they not followers?
No. That is when we talk about Zookeeper. The Zookeeper handle the servers like that. Yeah, now we are in HBase.
Okay.
In HBase, we have the HMaster and the region servers. Okay, so we have the region servers. We'll try and see if we can get that. Let's see. Something nice. Yeah, there we go. So we're gonna have the first one. We have the HMaster, and then we have the region server. And you need to remember that one of the part of the software that will control that will handle control the whole that will coordinate how the clusters state will be Zookeeper. So Zookeeper can be used together with HBase. So with HBase, we have the HMaster, which will basically manage all the meta data, and then we have H region servers. So these region servers will be the server that will serve the data for read and write. Okay. So so how do we apply, in what scenario, what type of scenario we can use HBase? HBase can be used in any real-time read or write access to big data, in any application that is requiring random or real-time access of data. We can use it in time series. Remember last week I spoke about time series data, so data that are depending on a certain time. So there's something that previously happened. For example, messaging, like sending messages and all those things. So in message systems as well, sensors, so we use HBase. Okay, so this is the architecture of HBase. Remember, it consists of the following components. We have the library function, we have HMaster, and the region server. You can either say region server or H region server. And last week we spoke about this. We can have all these. It's fine. So the region server is the core module of HBase. It provides the following main. It maintains the region allocation and responds to users' read and write requests. So basically, the region servers will serve the data for read and write. Okay, with the last time. Okay, so in terms of HBase, HBase key processes, right? So this is basically the processes that happen in HBase. So, because remembering that HBase, we are actually managing all the data, which can be in different clusters of hardware. So basically, picture it as you have many servers with certain data, and all the data are being used. So in the whole process, we need, remember, we have, as part of the architecture, we have the H master and we have the region servers. So basically, the H master will basically be the primary management process in HBase, because the H master will manage all the table metadata, right? So creating, deleting tables, so the metadata is basically those information that give us the directory, the name, so that's very important. So, because remember, we need to, so when you write the data, for example, so in the process, we have the read and write process. So when we dealing with read and write process, so we will, the data is allocated to the corresponding H region server, and who will allocate that? It's the H master. So the H master will basically create all the tables. It will assign all the regions, right? So it's going to distribute all the data in terms of regions to take them to the right region servers. Okay, so it's going to ensure that there's a even distribution of regions. Okay, so if, for example, you want to make a change a family column, the column family or something like that. So this is controlled by the H master. Okay, so something that is very important is that you can have multiple H masters. If you have so many data, you can have multiple H masters, but there can only be one active at a time. Okay. So now in the process, we have the H master, which will allocate all the data to the corresponding H region servers for execution. So the data will first be written to memstore and hlog, and then we use the commit invocation to return the data to the client only after operation written on hlog and memstore. Okay. So when you were reading the data, the H server first access the memstore cache. If the memstore cache cannot be found, the H region server searches store files on the disk. Okay. So this is an example of cache refreshing. So so if you want to understand how the memstore works, so the memstore is basically like a disk storage. Okay, so the system, in terms of cache refreshing, the system will just write the content in memstore, which is like the disk storage. Okay, so the system will write into memstore cache to the store file on the disk, and then you can clear the cache or write tags in the hlog. So a new store file, this is just to refresh the cache. So a new store file is generated each time data is written. Therefore, each store contains multiple store files. Okay. So, and then one thing to note, whenever you have in the cluster of multiple region servers, so each region server will have its own hlog, its own log file. So the log file is basically a file that will keep information about how many times certain data has been changed, what's the issue with the data. So this is a way where you can find out what's wrong with your system by just consulting what was recorded in the log file. So each time the region server is started, the log file is checked to confirm the latest startup. So it's going to check whether a new write operation is performed after the cache is refreshed. If an update is detected, the data is written to memstore and then store file. Okay, so this is how the process of refreshing cache. And then we have another process of merging store files. So basically, a new store file is generated every time the data is flashed, affecting the storage speed due to large number of store files. So then we have this function here, this code here, the store compact function, which is used to combine multiple store files into one. Okay. So another process can be implementing the store. So we need to know that in a H region server, the store is the core of the H region server. So when we have multiple store files, we can combine them into one store. Okay, so all the files, let's say we have the first file, which is about 64 megabytes, second file, third file, fourth file. So we can combine all these files, and then we create one big file, which is file here. And then this big file can be split into file 5A and 5AB, you know, and then we have 5.6, 5.7. So basically, we can combine multiple files and create one store file. Okay. So when the size of a single store file is too large, splitting is triggered. One parent region is split into two sub-regions. So this is an example here. When the file is too big, it can be split. Okay, so in terms of implementing the log, which is the file that will keep all the memory. So it will basically keep all the history of every changes or any modification of files. So we need to know that we need to consider that the system will usually, or sometimes the system can have some errors. So when you have a problem, you have a problem with your system, you will want to know what is the problem. So there needs to be a way that the system is recording those changes, is recording those problems. So what will help you is the hlog file. So the hlog file can log and can record all it can record all the errors that happen. You see, so the hlog, so it's just a file, it's just a log file, but because we're in HBase, we call it hlog file. Okay, so basically the hlog file will help you to make sure that if you want to recover your system, the hlog file will have the information. Okay, so this is a critical component of the in HBase. So this will help when you have a crash recovery, you know, so it record all the changes, everything that you write, every update, every moment you deleted something. So this will help you in case you want to recover certain files. Okay, so the HBase system, we will configure the hlog file for each region server, which is write ahead log. So that's how they can also call it, a write ahead log. This refers to hlog. Okay, so now when we update a file, this can be written in memstore cache only after the data is written to log. In addition, the cached data can be written on the disk only after the logs corresponding to the data cached in the memstore are written to the disk. So, to not say hlog, what is hlog? Hlog is just a file that will record all changes, write, update, delete. So all the changes to the files are recorded in the hlog file. All right. Okay, so this will just show the more H files, the more files we have, the more we have a latency into the processes. Okay. Uh, can anybody tell us what is an H file? What is an H file? Before we continue, what do you understand? What is an H file? Can anybody tell us?
Isn't it the actual data, like that is on HBase?
Yeah, it's so basically remember when we talk about the process of how the files uh, are saved, right? Remember we first go through the mem store. We have the file hlog that will notify if we're writing a file and everything. So now an H file is the final version of the file which is locked. So that file, it means that the file now is locked onto the disk, whatever memory we have it. So we have the file on the disk, which is locked with all the information about the metadata and all the information. You understand? So, but when we talk about the main store, so basically, if we have, for example, we put a new file there, we write the file, it first goes into the main store before it can actually be stored into the data. Think about it like, let's say, for example, when you're writing on a Microsoft Word, you're writing something, a document, somehow your computer is already recording what you are writing. Because if you click on undo, if you click on control Z, for example, it's going to go back and remove certain things you write. If you put control Y, it's going to move forward. That means it's memorizing somehow, even if your document is not saved. So this is how this works as well. So when you look at Microsoft Word, when you write things without saving first, but the information are there already, they are the machine kind of remember that. So that's the part, the mem store. So the mem store will remember the operation, remember the file, but it's not saved completely. And then when it is definitely flashed from the mem store, it's now saved properly. It's now saved completely on the disk. So now that the files are saved completely on the disk, that's when the files are called are called H file. So you need to remember an H file is we said it's immutable, that cannot be changed easily. So basically, an H file is just a file that is immutable. The final file when we're saving in HBase, right? We store data, and these data are saved on the disk itself in HDFA, a distributed file system. Okay, so it is basically the final destination where the data are saved after being flashed from memstore. So we have the X file. Okay, and then we can have what we call a compaction. So a compaction will actually be the compaction is actually a process to help to just merge H files. So when we talk about compaction, so we are merging the files. So basically, we have all these small H files. We can merge them into one large H file. So this can be considered to be a minor compaction. So when we talk about the minor compaction, so we are actually merging small files into one file. And when we talk about major compaction, so we basically compact all the files. We're not even leaving one. So we remove everything. So there's no more H files. We only compact all of them into one big one. So this is what they call a major compaction. All right. So why do we do these compactions? We do them just to improve the performance because we can create all, instead of having multiple H files, we can just create one major compaction to create one major H file. Okay, so let's talk about the open scanner process. So basically in this process, we have two different scanners which are created. So these scanners will help us to read H file and memstore data. Okay. So the scanner that is corresponding to H file, the one that will help us read H file data, is the store file scanner. And the one that will help us read memstore data is the memstore scanner. Okay. Okay, so what are Bloom filters? So Bloom filters will just be used to optimize some random read scenarios. So that can be the get scenario. So what does it mean? It means that we will have actually have, when we have certain, we're trying to get certain data from our database, for example. So we can use what we call Bloom filters. So basically, what will Bloom filters do? So they have a possibility to mischarge when we determine whether a piece of data exists. So when we're trying to detect that, so the Bloom filters will help us to detect if the data exists or if it don't exist. So basically, how do they work? They work in terms of probability. So it's basically kind of a probability data structure that we use in HBase. So these happen mostly into the read operation. So it's going to check, so this process is going to check if a row key or column might exist in H file. So we have all the H file. Remember, we said every cell will have a row key. I mean, every row will have a row key. So we have a row key at each level, and then so these Bloom filters, these are optimizers. So these optimizers will check to confirm if a certain H file exists. Okay. So instead of you scanning all the data to find if a file exists, you can use Bloom filters, which will actually check if those files exist by checking the row key. Okay. So we can have many types of Bloom filters. Okay, so in terms of performance tuning, so row keys are stored alphabetically in an alphabetical order. So remember, we have the keys. Depending on what pattern you're going to use, if you're using, for example, numbers, it's going to be in an order when it starts from 0 to whatever number. But if you're using alphabet, it's going to follow the alphabetical order. So if the data, for example, you write data in HBase table, and then you want to access them. So you can access them through row keys, and row keys are in an alphabetical order. So it's going to be very easy for you to get access to those data. Okay. So there are three methods to access rows in HBase table. The first one could be to access through a single row key. If you know the row key, you can access them, or you can access through a row key interval, or do a full table scan. But to do a full table scan, you must just make sure that the table is not that big. You don't have a lot of, but if you have millions of data, this is going to be difficult. Okay, so when we're creating database, we have what we call the index secondary. Okay, so these are the features. So basically in HBase, we can create HBase tables with multiple table indexes, multiple column indexes, index based on some column value. Okay. Common HBase shell commands. So, okay, so these are certain commands. What is a command, right? So basically, a command is just a code that is used on any platform to perform a certain task. Okay, so let's say you are in Python programming. In Python programming, if you want to display something, if you want to display a certain sentence or display a certain thing, you're going to use a command that says print. So print, and then you write whatever you want to print. So this is just a command you give to the computer. Okay. So when you look now in HBase, certain commands can be used. Okay. So if, for example, you don't know what command you should use for something, if you use the command help will list all available commands, and then it's going to show you different commands. For example, if you use the command create, this is to create an I table. List is to list all tables in HBase. Put would add data to a specific cell in a table, right? Row or column. Scan will browse all the information. Get will obtain the value on the cell based on the table's name. Okay, so you have drop, which will be deleting the whole table. You have many other commands, such as exit, which will exit the whole HBase cell. Actually, you have version, which can display what version of HBase you are using. So you have many commands that can be used in HBase. So you look at, for example, a command put, which is used to add the data to a specific column. So when we're looking at that now, when you look in this example here, so we run this command put, which will write the data into memstore, and then we can get it into H file. So we have all this H file, and then we can take it from there. Okay. Okay, so just to summarize, this part of the course I just described, HBase database. HBase is just an open source implementation of big tables. Similar to big table, HBase supports a large amount of data, distributed concurrent data processing. It is easy to explain, supporting dynamic scaling, and it is applicable to inexpensive devices. Additionally, this course describes the difference between the conceptual view and physical view of HBase data. HBase is a mapping table that stores data in a fair, multidimensional, and persistent manner. It uses row keys, column keys, and timestamps for indexing. And each value is an unexplained string. So this is about HBase. Okay, so we have a few quiz here. Okay, so we'll try this. Which of the following is type used to store data in HBase? Anyone? Anyone? Can anyone answer that?
I think it's byte. It's a byte.
Yeah. The real answer is byte. So basically, remember we don't have any coding, we don't have any coding. So basically, all the data are stored in byte arrays. So all the data are stored in byte arrays. So which will include all the information in terms of the row keys, the column family names, the column qualifiers, all the cells values, the timestamps. So all those are saved in the type of byte. Okay, so this is how it works. So basically, an example can be, let's say, for example, your column family. I don't know if I'm gonna be able to write here. Not allowing me to write here. Let's see, I wanna see if it can allow me to write anywhere. Okay. Okay, I'm not sure. Not giving me an option to write. Okay, so basically, but okay, fine, I can explain it. So basically, if you, let's say your cell value, right? Your cell value as a name of someone, and the name is something like Alice. So if the name is something like Alice, in the HBase, it's not gonna save as Alice. Alice is like a string, it's like a name, but it's going to save it in a byte representation, which in this case will be like an hexadecimal byte that can be maybe 41, 60, 69, something. You know, it's like numbers, those bytes representation. That's how the data are saved. Okay. So the next one will be, what is the smallest storage unit in HBase? This is easy, guys. What is the smallest storage unit in HBase?
A region.
Sorry?
A region.
The region. Okay. Anybody else think it's the region? Anybody think it's a region?
Isn't it like a unit?
Sorry?
Isn't it a cell? Sorry.
Yeah. You think it's a cell? Okay, anybody else have a different answer? Okay, so the right answer will be a cell. Because remember, we have a big region, and in a region, we have a column family. Inside the column family, we have columns, and inside the columns, we have rows, and then the intersection between a row and what you call that, and a column, that's where we're going to have a cell. So basically, a cell is part of the column. Column is part of the column family, and the column family is part of the region. So a region is bigger. So the smallest storage unit will definitely be a cell. So the cell represents just a single data element, while you have the column families, which represent many data. Okay. All right, guys. That will be all. And tomorrow we're going to start with MapReduce and Yon platform. Okay, guys. Any question? Any question before we call it a day? Guys, please note that if we complete on today, Tuesday, if we complete on Thursday, if we are done on Thursday, this means that if we finish on what is that Thursday, which means that next week is the only week we're gonna have as to prepare for the exam, and then end of next week or beginning of the following week, that's when you're gonna write your exam. So, and the same week we're going to start with AI. Yeah. So AI is gonna be very interesting because you're gonna have a lot of things very interesting to go through. So please know that you only have next week, the whole week, to prepare for the exam. Okay. Any questions?
I just like to ask, some of us are writing.
Can you speak a bit louder? Can't really hear you.
Okay, can you hear me now?
You are muted now.
Okay. I just wanted to ask, like, since these following weeks, some of us are writing tests and exams, will there be provisions if we like miss class, or we just have to catch up using the material online on the slides only?
Yeah, remember I've asked everyone to send me a message to give me to tell me when are your exams in school, but I only had like two messages. I only had two messages, so it's very difficult to plan considering everyone because nobody responded to that suggestion. So I think uh, to writing next week, I think you will have to find some time to catch up because for any class that you miss, if we've recorded it, you can find it here on Microsoft Meet Teams. I mean, you can find it here, the recording, or you can also go if you're already registered on the Huawei Talent. You can also go through the Huawei Talent videos. If you have a question, then you can send me a message to ask about that.
Sir, have you uploaded the material on that thing that link that you had sent, that one, ka?
No, I have asked that they send me the updating material. I think by tomorrow I should be able to upload. But for now, you can only access it through those videos. But if you want something like a PDF, I think by tomorrow they should send me the updated one.
Okay, thank you, sir.
Yeah. Any other questions? All right, guys. I think we can just check the attendance screenshot, and then from there we can just turn on your camera. So from there we can check the attendance and call it a day. All right, guys. Okay. I will see you tomorrow. Please do not miss tomorrow's class because we're gonna be going a bit faster and complete it by Thursday. So next week we can start with AI. Okay, guys. Have a great evening. I will see you tomorrow.